Okay, hi everybody. We are going into our final section of Chapter 6, that is Section 6.4. And what we are talking about in this section is the volume and the surface area of spheres. Now, the volume we have talked about at length with several other shapes, but the surface area is something that's new and maybe something that we haven't heard about before. So just keep your ears open when we talk about that, and we'll try to figure that out together. Okay? Let's get right into the lesson today. Well, first of all, the problem of the day. I will give anyone extra credit who has an ability to figure this out. It is not hard. I invite you to read it carefully and use your brain. I think many of you would be able to get it if you tried. Okay? Now we will get started with a do now. First, find the area of a circle with radius of 8 millimeters. Second, find the area of a circle with a diameter of 2 feet. I invite you right now to pause the video and try to answer these questions on your own, because in about 10 seconds I'm going to start working on them together. But if you can do these now, you will have a good chance to be able to do it on an assessment. If you cannot do these now, it will be harder to do them on an assessment when you are asked to do it for real. Okay? So, first of all, we are going to find the area of a circle with radius of 8 millimeters. And we are going to remember that the formula for area of a circle is equal to pi times the radius squared. And that's it. Okay? So all we are going to do, pi stays pi. We are just going to replace our radius with what we know it is. Area of a circle is equal to pi times 8 millimeters squared. Okay? 8 millimeters squared, 8 times 8 is 64, so I get 64 millimeters squared, because when you square millimeters, you get millimeters squared, and you have area of a circle equals pi times 64 millimeters squared, but the way that we normally write that is area is equal to 64 pi millimeters squared, because we like the number to go in front, the coefficient, the 64 right here. Okay? So the area is 64 pi millimeters squared. That is my perfect area, but it asks me, no, it doesn't actually ask me to do it in terms, not in terms of pi, but I will ask you right now, give me this answer to the nearest tenth, and so what we'll do, we will say area is approximately equal to 64 times 3.14 millimeters squared. And when I use a calculator to do this, I get 64 times 3.14. I get that its area is approximately equal to 200.96 millimeters squared. But I want this to the nearest tenth, so what I will do, I will round to right here, and I check the number right after it, 6. 6 tells the 9 to go higher. So something funky happens when you have a 9 and you're going to round it up. You get that the area is approximately equal to 201.0. Okay, because the 9 has to go higher, it turns into a 10. But we can only fit the 0 of the 10 right here, so the next one has to become the 1%. So to get 201, area is approximately equal to 201 millimeters squared. And there I have my answer to the nearest tenth. Now we are going to do the next one. Find the area of a circle with a diameter of 2 feet. Well, I look at my formula for area again. Area of a circle is equal to pi r squared. However, I don't have my radius. You have to notice that. I do not have the radius anymore. They give me the diameter. So I'll draw a circle here. I know that my diameter, this length right here, is 2 feet. But I want to know what is my radius. Radius, remember, is always half the diameter. So the radius would be 1 foot, which is half of 2 feet. Okay, so radius, I'm going to draw it in right here. Radius equals 1 foot. And then I can do my formula from here, because the radius is what I'm going to replace. The 1 foot. Everything else stays the same. I get area of a circle is equal to pi times the radius squared. So area of the circle is equal to pi times 1 foot times 1 foot. 1 foot times 1 foot is just 1, because 1 times 1 is 1, foot squared. And so when I multiply pi times 1, well, what do you know? I just get pi. So area of my circle is equal to pi feet squared. And that is my perfect answer. There is a number if you want to draw it in. It's the 1. But you don't have to. It's just pi. Okay? Pi feet squared. That is my perfect answer. And if I wanted approximate to the nearest tenth, well, it's approximately 3.14 feet squared. And when I round that to the nearest tenth, I just take off the 4, and I get my area is approximately 3.1 feet squared. Okay, that was a good question, and we are going to go into some new stuff today. Keep these things in mind, though, because there is a reason that I picked them. Okay. So, how many of these shapes or parts of shapes can you name? Well, we've got two things here, and as you can notice, they are 3D. One of them looks kind of like a ball, and one of them looks kind of like half a ball, or a bowl upside down. Okay? Let's see, where did I put these? Okay, so this right here is a sphere, and the red line, as usual, is the radius. The blue point right here is going to be the center of our sphere. Okay? And when we go over to this half of a sphere over here, it is exactly that. It's half a sphere, or we use the word hemisphere. Hemi meaning half. Okay? So we have a hemisphere here, and notice this green line that goes around. If this was the Earth, this green line would be the equator. Okay? That line right there has a special name that you might never have heard before. This is called a great circle. A great circle is any point or any circle around the around our circle or around our sphere. So if we have another sphere right here, okay, then this blue line I drew in here, that is a great circle. But I could draw another one like that, or I could draw. Let me grab another color. How about purple? I could draw another one right here. Okay, purple didn't work. But you get the idea. We can draw any number of great circles. It just has to go completely around the sphere. Okay? So there is our vocabulary that you will need to know. And let's define it a little bit more. A blank is a set of points in 3 dimensions that are a fixed distance from a given point, the center. Well, let's think about that. We have a center, and if I want to take the collection of all of the points that are, say, 1 foot away from this, I'd get a point here, and a point here, and a point here. Okay? This one clearly shouldn't have been there. Okay? So I've got this roughly circular shape that goes around. But remember, I'm not talking about 2 dimensions anymore. I'm talking about 3 dimensions. So what I will end up getting is a sphere. 1 foot, every point on the sphere would be exactly 1 foot from my center point. Okay? So a sphere is the set of all points that are a fixed distance away, and that distance is called the radius. Okay? A plane that intersects the sphere through its center divides 2 halves. So if we cut our sphere in half, as we saw on the previous slide, the 2 halves would be called hemispheres. And the edge of a hemisphere, so let me direct your attention to this figure down here. We've got this hemisphere right here. Okay, this half sphere here. The edge of it, which is right here, that is called the great circle. Okay, that is the circle that goes all the way around, like a hemisphere. Okay, and we're caring about volume and surface area. So the volume of a hemisphere is exactly Okay, I'm going to have to move this. Halfway between the volume of a cone and a volume of a cylinder with the same radius and the height that is also the same as the radius. Well, what did I just say? Let's think about that. Here in green, I have this hemisphere. Okay? Notice how it looks like it's halfway between this cone right here and this cylinder. Let me grab a different color. And this cylinder right here. That didn't work. Okay. Okay, so I've got this cylinder right here. I've got in between it and the cone, I have this hemisphere. So the volume of a hemisphere is exactly halfway between the volume of this cone and the volume of the cylinder. Okay? So just keep that in mind. Okay, now let's talk about the volume of a sphere. The volume of a sphere is 4/3 pi the cube of the radius, r. What does that mean? Well, let's look at the volume and the formula for the volume, and that might be a little bit easier. The volume is equal to 4/3 times pi times the radius cubed. And the only thing scary in there is, well, maybe the cube for some of you, the raised to the third power, but the 4/3 some of you are going to freak out on. But it's really not that hard. Okay, it's just 4/3. You multiply by 4, divide by 3, and you're done. So 4/3 times pi times your radius cubed. And once again, the only piece of information we need in order to find the volume of a sphere is just the radius of the sphere. Okay? So let's do this example that we have right here in numbers. Okay? We are given that the radius is 3. We don't know what the units are, but we'll just call them units. We know that the radius is 3, so I start with my formula. 4/3 pi times the radius, which is 3, and then that gets raised to the third power. Okay? So the first thing we're going to do is evaluate. Well, I don't like the way they did it there, so I'm going to do the rest of it. Okay? First thing we do is we evaluate the 3 squared. We get 9. Okay? And then the rest of it stays like this, 4/3 times pi times 9. But I'm working with fractions, so I'm going to make this easy on myself. First of all, I'm going to move the 9 to the front and turn it into 9/1 times 4/3 times pi. Okay? And what you guys are certainly thinking to yourself already is, hey, I should simplify or cross-cancel. This 3 and the 9 have a common factor of 3, so I will divide that common factor out. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. And so now I have 3 times 4 times pi. Well, 3 times 4 times pi is equal to 12 pi, or 12/1 pi, which doesn't make a difference. So 12 pi, and then to find my approximate answer, I just do, this is approximately 12 times 3.14. And when I use the calculator to find that answer, I get 12 times 3.14. This is approximately equal to 37.68. So this is approximately 37.7. And then I go back and I look for my units. I don't see them anywhere, so I'm going to throw in units cubed, because I'm using volume. And the same thing over here, units cubed. And there, the 12 pi units cubed is my perfect answer. The 37.7 units cubed is my approximate answer. And I am done. That is all there is for finding the volume of a sphere, just using this simple formula. So, we have 2 practice problems. First of them is to find the volume of a sphere with radius 12 centimeters, both in terms of pi and to the nearest 10. And we're going to use 3.14 for pi. So, first thing I'm going to do is draw a sphere, just because I like to. Okay, and I'm going to label in my radius, which is 12 centimeters. Then I'm going to use my formula. Volume equals 4/3 pi times the radius cubed. So now I just need to plug in the given information, which is my radius. Volume equals 4/3 times pi times the radius, which is 12 centimeters, raised to the third power. Okay? So, first thing we're going to do is I'm going to do 12. I apologize. I'm going to go back 1 second because I did make a mistake here. And I am very sorry about that. This 9 over here, I did 3 squared. That should have been 3 to the third power. 3 to the third power is 27. Okay, so this 27 should have been here. When I reduced, I would have gotten, instead of 3, I would have gotten 9. And so instead of 12 pi, I will get 9 times 4, which is 36 pi. And then instead of 37.7, I get 36 times 3.14, which is 113. And it's 113.0 units cubed. I apologize for that. I was rushing, and this is the problem you get when you rush, right? So the first thing I'm going to do over here, going back to this problem we just left, is I am going to find what 12 to the third power is, which is 12 times 12 times 12, and I'm going to use a calculator to do this. And I get that this is 1,728 centimeters cubed. Okay? And then I'm just going to bring down the 4/3 pi. All right? Volume equals 4/3 pi times 1728. Now what I am going to do is I am going to multiply 4/3 by 1728. So I'm going to rearrange this 4/3. I'm going to put pi all the way at the end. And I'm going to do times 1728 over 1, and then times pi. That is my volume. So what I am going to do now is I'm going to see if 1728 can be divided by 3, and it can. Okay? I used a calculator for this because I don't know the factors of 1728 off the top of my head. But I know that 1728 divided by 3 gives me 476 using the calculator. And 3 divided by 3 just gives me a 1. So I can still simplify this. And now what I have is that my volume is equal to 4 times 476 times pi. And 4 times 476, again using the calculator, I get that the volume is equal to 1904 pi, and this is going to be centimeters cubed. There's my perfect answer in terms of pi. And now I'm going to want my approximate answer. And the way I do that, once again, as always, volume is approximately 1904 times 3.14. I use my calculator. I get that the volume is approximately 5978.56 centimeters cubed. And I will round this 0.5 with the 6 after it to 0.6. So 5,978.6 centimeters cubed is my approximate volume. Now what I'm going to do, find the volume of a sphere with the diameter of 4 feet, both in terms of pi and to the nearest tenth. And the reason I put this question in is not because I think we need more practice with it, although that doesn't hurt, but I want you to notice you can't just plug blindly into a formula and assume that you'll be right. You need to understand what the question is asking. And here it is saying you have a diameter, not a radius like you had in the last question. So we will draw our sphere, and instead of having the radius, this time we have a diameter of 4 feet. Only problem is when we use our volume formula, volume is equal to 4/3 pi r cubed we don't have a place to put diameter. We need radius. So we will need to find the radius, which is this point from here to there. Radius, and that's going to be half of the diameter, which is 2 feet. Now we can do our math. We get volume equals 4/3 pi. My radius I'm going to change to 2 feet, and then I'm going to cube that. Everything else stays the same. Volume equals 4/3 pi times 2 feet cubed. Okay? Well, 2 feet cubed is 2 feet times 2 feet times 2 feet. 2 times 2 is 4. Times 2 again gives me 8. So I get 8, and then feet times feet times feet is feet cubed. So I'll get 8 feet cubed. Everything else stays the same. 4/3 pi times 8 feet cubed. Once again, I'm going to bring 8 to the front. I'm going to leave off the feet for a second just to make it easy. So 8 times 4/3 times pi. And just for the heck of it, I will put 8 over 1. And I will say that this is my volume. I will look to simplify it. But I will quickly notice the 8 and the 3 don't have any common factors. 4 and 1 don't have any common factors. 4 and 3 don't have any common factors, so I can't really simplify this the way I often can. So what I will do is I will just multiply across. I get that volume is equal to 8 times 4 is 32 over 3 times pi. 32 over 3 times pi feet cubed. Now if I try to do this on a calculator, this is my perfect answer, by the way. Now if I try to do this on the calculator, I'm going to make sure that I put parentheses around my 32 over 3 so that the answer comes out all right. I get 32 divided by 3 times 3.14, and I get that volume is approximately 33.49. So volume is approximately 33.5 cubic feet. And I'm done. That is the volume of this sphere. Again, make certain that when you are looking at your problems, both the one up here, you see if you have a radius. You do, so you can use your formula. Over here, you notice that the diameter is what is given to you, so you need to find the radius by dividing the diameter by 2. Okay? Now, here are a couple of questions that you are going to work on. Find the volume of each sphere in terms of pi and to the nearest tenth. You may use a calculator for these, but you must do these. Okay? And then we're going to talk about our last thing, the surface area of a sphere. The surface area S of a sphere is 4 pi times the square of the radius r. Huh? Well, first of all, we need to know what surface area is before we can actually find it, right? Granted, we could use a formula and find something and not have any clue what we're doing, but I don't feel like that's really useful. Surface area is different from volume. The surface area is just what it says. It is area. So let's take the area of a rectangle. Let's say this is 2 and this is 4. The area of a rectangle is equal to 4 times 2, length times width, so it equals 8. Okay, that's pretty easy, and what we're talking about is how much stuff it takes to fill in this surface. If we wanted to completely color it, how much green, for example, would I need right here to completely cover that? And I would need 8 square units. Let's say these were centimeters and centimeters. I would need 8 square centimeters of green, whatever this is. Okay? That is area. But when we talk about three-dimensional objects, like a cube, okay, let's say that this is 2 feet times 2 feet times 2 feet. Okay, this is a cube. Every side is the same. Then when I talk about area, well, what we have been talking about is volume. Volume is how much stuff it takes to fill up this shape. But let's say I didn't want to fill up this shape. Let's say I just wanted to color the outside of it. Okay? How much blue would it take to color this face, and this face, and this face, and this face, etc.? There are 6 sides to a cube. If you have maybe a pair of dice or something, you can look at it. You see there are 6 sides to a cube. All I want to do is cover the outside. That's what surface area is. Surface area, how much surface there is on the outside. Of a 3D figure. Okay? So that's surface area of a cube, which we did not talk about. But to find that, we would just find the surface area of each side. They're all the same. Okay? So the area would be 2 feet. Area of one side would be 2 feet times 2 feet, which equals 4 square feet. Now that's the area of one side, but to find the surface area, there are 6 sides, so I would have to multiply 4 square feet by 6, and I would get that the surface area of this cube is 24 feet. And we are still in square units because we're talking about area, even though it's a different kind of area. Okay? So now let's talk about surface area of a sphere. And all that is the exact same thing. How much it would take me to completely color in the outside. So let's say I had the Earth. How much would it take me to completely cover the Earth with something, like say a blanket? Or if I had a ball, how much, say I wanted to color it in with a pen, how much ink would it take me to completely cover the outside of the ball? That's what surface area is. Now let's figure out how to find it. So in words, I have that the surface area is 4 pi times the square of the radius. The formula is easier. And we abbreviate surface area with S, and we get that it is 4 pi r squared. So really, look at that. Pi r squared, that looks familiar. The surface area of a sphere is really 4 times the area of the great circle, okay, which is the area of the circle in the middle. So 4 times the area of this guy right here, okay? Or you could just use the formula. So let's try it with this one. We have the radius is 2. Okay, the radius is 2, so I will just do 4 pi times the radius squared, which is 2 squared. So this 2 comes over and gives us this guy right here. Now, first thing I will do is I will say, hey, 2 squared is 4. And then I have 4 times pi times 4, which I know gives me 16 pi. And that is my perfect answer. I have it already, 16 pi, and I don't know what my units are, so I will say units squared. That's my perfect answer. But I want an approximate answer too, of course. So 16 times 3.14 units squared. 16 times 3.14, when I do it on a calculator, I get 16 times 3.14 equals, this is approximately 50.24. So that is approximately 50.2 if I want it to the nearest tenth. And once again, unit squared because I'm talking about surface area, not volume. Okay? And that's all there is to it. So, I have a couple of questions that we are going to do very quickly, and then we are going to be done. Find the surface area of the sphere below, both in terms of pi and to the nearest tenth. Okay? I want surface area, so once again, I'm going to start with my formula. S equals 4 pi r squared. Now, I look, do I have my radius or diameter? I have a radius, so I am good to use my formula. I will do S equals 4 pi times the radius, which is 3 squared. 3 squared is what I'm going to start with. I know that 3 squared is 9. Everything else will stay the same for a moment. So S equals 4 times pi times 9. Okay, and we're inches squared. Okay, 4 times 9 gives me 36. So I have 36 times pi inches squared. This is my surface area in terms of pi, which gives me a perfect answer. Now all I'm going to do is I am going to multiply by 3.14 to get an approximate answer. So I get 36 times 3.14, and the calculator says that that is 113.04. So this is approximately, to the nearest tenth, 113.0, and I am inches squared. That's all there is to it. Just plug into the formula. Don't make any mistakes when you're multiplying. Get it in terms of pi and to the nearest 10. Now, we are given another one. Find the approximate area of the surface of the Earth. The radius of the Earth at the equator is 3,978.87 miles. Now that looks ugly, which is why this word is my friend, approximate. So right off the bat, I'm going to take this, I'm going to cross it out, and I'm going to say, hey, that's pretty close to 4,000 miles. Now I'm going to look to see if I have the right information. It says the radius of the Earth. Radius is what I want, so I can go ahead and do this. S equals 4 pi times the radius squared. Well, that's 4 times pi times 4,000 times 4,000. Well, 4,000 times 4,000 is 16 with 6 zeros after it. So I get 16,000,000. That is 16 million square miles, which, if you don't have any way of understanding what that means, it's big. So I get 4 times pi times that big whole number. So what I'm going to do is I'm going to multiply my like terms first. I'm going to multiply those two guys. 4 times 16 million is going to be 64 million pi miles squared. Okay, so that is my surface area exactly. Well, approximately. I guess I did approximate this, so all of this should be approximate, because 4,000 was not accurate. So this is approximate, and so if I wanted it to the nearest 10, I would do S is approximately 64 million times 3.14, and I will get that it is a big number, 200,960,000. Let's see. Did I do that right? I might have not enough. 1, 2, 3. Yeah. So, 200,960,000 miles squared. Okay, and that's all there is to it. These questions are going to be for you right here. You must do them. 5 and 6. Find the surface area of each sphere in terms of pi and to the nearest tenth. Make sure you have radius for both of them. And if you don't, make sure you get it. And then summary questions. Explain which would hold more water. A bowl in the shape of a hemisphere with a radius 5 inches. A cylindrical glass with radius 5 inches and height 5 inches. Or a that says conical. I apologize. That should say conical. That means cone-shaped drinking cup with radius 5 inches and height 5 inches. I invite you to draw all 3 of these things and see which one you think would hold more water. And then you can find the volume if you'd like in order to prove that you are right. But I think you can do this question without actually needing to talk about volume. And what we're going to do, we're actually going to do it together. Here's my cylinder. Radius of 5 inches, height of 5 inches. here's my cone. Height of 5 inches again. Radius again of 5 inches. And then my hemisphere, finally, is going to have a radius of 5 and a height of 5. And which one of these does it look like would hold more water? If you flip this whole thing upside down, which, hey, you know what? I've got a smartboard, so I'm going to do that. And we filled all of these with water. Which one's going to hold the most water? Is it going to be the red one, the black one, or the green one? So I leave that for you to figure out. And then finally, number 2, which one is bigger? The area of a great circle for the following, or the surface area for the following sphere? Okay? The area of the great circle, remember, is basically the area of the circle that is the equator. Okay? So that area equals pi r squared, as area always does. Okay? But I don't have my radius. Look, this 20 centimeters, that's the diameter. So the radius is going to equal 10 centimeters. I really invite you not to make this mistake. Area equals pi times 10 centimeters squared. 10 centimeters times 10 centimeters is 100 centimeters squared. And then don't forget your pi, like I almost did. So 100 pi centimeters squared. So that's my area. Area equals 100 pi centimeters squared. So, if to do approximate, I will multiply this by 3.14. Area, well, yeah, area is approximately 314 centimeters squared. Okay? And now we just have to find the surface area of this and see which one's bigger. If we find the surface area, that is S equals 4 pi r squared. Well, I'm already going to cheat because I look at this and I say, I don't need to do this whole thing. I just need to do pi r squared. Well, I've already done pi r squared over here. So area equals pi r squared. So it's really this approximately 314. That goes in here. So my surface area is equal to 4 times 314, or approximately 314 centimeters squared. So which one's going to be bigger? Certainly this surface area, because it's 4 times the size. It's multiplied by 4. We are done. The end of the video. The end.